Hello. Good morning. Can you hear us?
Hello.
Oh, hi, Ricardo. It's Kobe. Please bear with us. We're just connecting the screen.
Hello.
Oh, you cannot hear us.
I can hear you.
You can hear us. Okay. Okay. There you are. Okay. Let me go. Let me do this.
Hello, Ricardo, can you hear us?
Hello. Yeah, I can hear you.
There's a remote control. You might be able to control the volume.
It's too loud.
It sounds like it's quite loud. Yeah.
I can control it too.
But someone just do the mic check.
I'm just.
Anyway, you can control it here if it's too loud. There's the volume button.
Let me record this. Oh, it's recording already.
Okay, so should we
Whenever,
start?
yes, whenever you like, Ricardo. Yeah.
Okay. Okay, so just let me share my. Hey guys, so hopefully you are seeing my screen now.
Yes, we are. Yeah.
Okay. So what I will be going through today is making a short demo slash interactive tutorial of how we can use pygeoapi to serve OGC API processes requests with a custom process manager that bridges pygeoapi and Prefect. So the contents of the session are available online at this URL. So if you want to follow along, I suggest you to just use this, the URL and just try to do the stuff with me, or just have somewhere to read it better. So I am kind of assuming that you are familiar with Python and have heard about pygeoapi and OGC API processes, but you may not necessarily be super specialized in them. I will start by doing a small introduction to both OGC API processes and pygeoapi, and then we will move on to installing some software on our machines and do some sample OGC API processes requests, first with the vanilla pygeoapi manager, and then we will swap it out with the work that I'm demoing out here, the pygeoapi Prefect manager. Right. So as for OGC API processes, this is a geospatial standard by the OGC that basically specifies how you can offer computational resources to clients in order to generate domain results. So you can offer your own specialized algorithms, and you can have a web API that accepts requests from the world, basically, to generate results which are then made available to the caller. So just some basic terminology. So the standard speaks about processes, which are in fact the computation that the server is able to run. These may take some inputs and they generate outputs, which is usually what you would be interested in receiving as the result. The computation is performed after getting an execution request from a client, and it can be made either synchronous or asynchronously. And this means that if it's synchronous, the client needs to wait around with the open connection, that the result may be generated and returned back. And if the execution is asynchronous, the client can make a request, get back a quick response just saying, okay, the server has acknowledged the request and is going to be performing the computation eventually. And then when the results are done, the client can get them back. There are two ways that the client can know that the result is ready. One of them is to keep polling an endpoint that gives it the status of the computation, and the other is to specify a URL to be called back when the results are ready. So when the execution is requested and the server is about to start its work, it spawns a job. So a job is just let's say an instance of the process that is running. Okay, if you are interested and want to know more detail, the OGC API processes website has all the details, and you can get also the standard document. So look around if you need more information. Then for pygeoapi, it's just a small introduction. Is a Python web-based web app that implements support for a lot of these OGC API standards. It is actually a reference implementation for some of them, and for others it is just marked as compliant by OGC, which is still very commendable, and basically is a very good tool to go to if you are in need of exposing resources via OGC API standards. I don't know if at this point you have not heard of it, but in any case, here is a link for it, and to get all of the details about how it can be operated, how it works, and whatnot. So for pygeoapi Prefect, sorry, what we did was we tried to take advantage of the fact that pygeoapi is very flexible and can be extended by means of plugins to kind of fill in the gap in its reliability and robustness when it comes to serving processes. Don't get me wrong. I mean, pygeoapi is very serviceable in its OGC API processes support, but we just found that there were some things that we could improve upon, mostly in terms of controlling concurrency, allowing for a better room for scaling things out horizontally if we start to see higher levels of traffic. So we went to look for solutions that would allow us to, for example, provide isolated environments, have more nodes available for computation, and also being able to scale out the storage. So these are all things that are not part of the OGC API processes standard per se, but are things that we end up needing when we want to operate a service like this at scale. So we thought to look out for what tools are already in the market today, or in the wild, let's put it like this, that are already doing this type of, let's say, cloud native workflow orchestration type of use cases. There are many tools. We settled on one which is named Prefect. I'm not sure if you are familiar with it or not. Here is its website, and Prefect is just what we were looking for in terms of the conditions I was describing. So it is designed as a very flexible application that can be deployed with many types of infrastructure. So from a single server node all the way up to a full data center, to using cloud services for everything. So it seemed like a perfect fit for pygeoapi processes integration, because its core use case is indeed just handling how to perform data pipelines, whether on demand or via a schedule. It has a lot of features for dealing with retrieves, for controlling concurrency, has a nice user interface that allows us to monitor the execution and also to look back at historical events. So we set out to build a pygeoapi plugin to basically put Prefect as the process manager. In it, we kind of worked up these 3 different integration levels. The first one is just, you can achieve it by simply swapping out the built-in pygeoapi manager with this one, and just keep using your processes in sync mode. It would give you already some good advantages, namely the usage of Prefect user interface for monitoring and checking out, and using its result storage also for scaling out where you save your results. We will be taking a look at the UI in a short while. There are some cons also. So the main one is that it becomes a bit slower than the default pygeoapi process manager, because it needs to coordinate stuff with Prefect. These two that are here, that the fact that it runs in the same process as pygeoapi and it uses the same environment as pygeoapi is just a consequence of the fact that we are using sync mode. So stuff is being handled in the same environment where the main pygeoapi web application is already running. Then for the, let's say, the intermediate integration would be to simply start using the asynchronous execution mode, which allows us to already use a Prefect worker and to submit jobs via the Prefect scheduler. And this has the effect that it unlocks the control of concurrency. So basically it becomes possible to control how many jobs are allowed to run on the server at any given time. So let's say you receive a spike in traffic and are given, let's say, 1,000 execution requests at the same time. Prefect is able to just say, okay, I'm simply going to run these many, that you can say how many they are. Let's say, for example, 10 at each time, and the others will simply be left in the queue waiting around, and I will get to them whenever I can. So this is already a nice way to keep your server operating in, let's say, an acceptable range, and prevent it from running out of computational resources or RAM or whatever. And then we have the third integration level, which is to use pygeoapi with Prefect flows that you have already deployed onto whatever infrastructure you have. So this requires you to have a good knowledge of how to set up Prefect and how it can be operated. But in return, you gain a lot of features, because basically you can use whatever Prefect offers. So it means you can, for example, have a cluster that's running on Kubernetes, and you can be using multiple workers, and and you can basically control concurrency in very different ways. So if you have to, for example, if you have to access a database to perform your computation, you can have a limit that specifies how many jobs can be accessing the database at a single time. Or if you need to access a third-party web service, you can specify a limit to say how many requests can be made. So Prefect has a very rich feature set when it comes to controlling the limits of its overall cluster. And basically this third mode makes you use all of Prefect's features within pygeoapi. Today I'm going to stick with the level 2 because it's easier for us to have a small demo to play with. And I would suggest, if you are interested in this full-blown integration, to check out our docs and also the Prefect documentation. It can be a bit complex to set up. That's what I put here as the only disadvantage. But with this, let's say, with great flexibility, also comes a bit of a steeper learning curve. We've had success setting Prefect up in a multitude of different infrastructures and environments, even on air-gapped environments too. So basically this unlocks limitless possibilities. Okay, this is a bit more typed out description of each level, but we can skip. Just before we go to the practical stuff, I just want to give you a very brief overview of where we are going to with pygeoapi Prefect. It's already in a very usable state, so you can use it today to replace the pygeoapi process manager if you want. We will continue to maintain and improve it. When I say we, I mean the GeoBeyond, which is an Italian company, which has been kind of supporting this work and steering it. But pygeoapi Prefect is also a community project, so feel free to engage with us via GitHub, and if you want to participate, we are open to it for sure. The idea is to improve the listing of jobs a bit, and fix some smallish bugs that are still present, mostly with the display of jobs, to flesh out our docs with more examples and improve the user guide, which is here even. And we have a couple of missing functionalities that we need to implement related to the OGC API processes standard, which are the ability to cancel ongoing jobs and the ability to implement this HTTP callback. I'm not sure actually if pygeoapi core has implemented this miss already, but maybe, probably so. I think subscription is implemented in core. Both these features are not, let's say, they are not very hard features to implement, so expect these to land soon on the pygeoapi Prefect source code. And we will be also keeping an eye out for future OGC API processes parts and implement them as soon as possible. So this project is very much alive, and we are planning on keeping it around for the long term. So don't be afraid to use it. Okay, let's now start the practical session. I'm going to switch to a dual view. Hopefully everyone can follow along. So let me put here my terminal. Are you able to see my screen okay, both windows?
Yes,
I guess oh, okay,
yes,
thank you.
Again.
Thank you. Okay, so let's start out. I already went ahead and did this first initial step, which is the installation of pygeoapi and pygeoapi Prefect on my machine. Just a small note. Let's say I would like to say this month, but let's say in the current days, we still require that you install pygeoapi from its master branch rather than just doing a standard installation of pygeoapi Prefect and let it pull everything. as dependencies, simply because there is a bug in pygeoapi which has been fixed but has not been released yet. So hopefully the pygeoapi maintainers will do a release soon, and they will include this fix for this issue. Until then, and I do hope this will be a very short-lived workaround, we need to install pygeoapi from the master branch before we actually install pygeoapi Prefect. But basically, these first instructions are just to create an environment for us to play with, so a virtual environment with pygeoapi and pygeoapi Prefect installed. And I also pulled in a sample pygeoapi configuration file so that we can modify it and use it. Okay, so let's start out by testing the OGC API processes support in pygeoapi with its default process manager. Okay, so I'm just going to make a copy of the configuration file and I'm going to modify it. So this is the default pygeoapi configuration file. I'm just going to delete everything. Hopefully, no one minds that I'm just going over the copyright notice. I hope Tom is not here to be upset. And I'm going to change it with this configuration that I have prepared beforehand. And this is simply, oh, sorry. Wait. Here we go. Okay. Wait. Sorry. So this is just a condensed version of the initial configuration to fit on a single screen. And what I did basically was to enable the default process manager, which on the other configuration file was commented out. So, but if you just enable the default process manager, which is based on TinyDB, you already get OGC API processes support in pygeoapi. I should mention that there are two other built-in process managers. One is based on PostgreSQL, and the other is based on MongoDB. So you have the option to use those as well. They work similarly to the TinyDB manager. So we are sticking with this one just for ease of configuration in this session. Okay, now I have this one ready. I'm going to generate the pygeoapi OpenAPI document, which it requires in order to operate. So I simply copied the command and pasting it here. And we now have these three files on the directory. So our pygeoapi configuration file and our pygeoapi OpenAPI file. And with this, we can start the pygeoapi server. Okay. So I have given pygeoapi two environment variables to start. So the location of the configuration file and the location of the OpenAPI file. You can specify these in a .env file if you prefer, or you can just put them all in the same line when you call the pygeoapi command. So right now pygeoapi is running. If I come here to my localhost port 5000, I can see its default user interface, and I can already see here two sections that are part of OGC API, of its OGC API process support. So the list of processes, for which there is only one, and the list of jobs, which for now there is none because we just started it around. Okay, now let's look at what the API returns. So I'm going to open a new terminal. Oh, sorry, I made some mistake. Oh, sorry. I don't know what I did, but I meant to type here and I type on the other terminal. So I'm going to open a new terminal window just so that we can start doing these web requests. I'm using curl in this session. It's just a way to make web requests and test out the pygeoapi API. So at first, I'm just looking at the landing page of pygeoapi, just for you to note that the same way that we saw processes and jobs being advertised on the user interface, we also see them being advertised here on the at the API level. So here we have the endpoint for processes, and here we have it for jobs as well. So now let's just take a look at the listing of processes. And you can see that there is a single process. Its name is Hello World, and its ID is also Hello World, which is actually the same output that we got here, basically. This also contains a description of the process, but it's mostly an overview. If we want to get the details of how we can call the process and how we can interact with it, we need to take a look at the process details endpoint, which gives us back information about how the process can be operated. So there is a list of inputs that the process takes and a list of outputs. For each of these, there is a mention of its identifier, and most importantly for us, what its schema is and how many times it can be specified. So, for example, there is, let's look at this message input, that we can see that its name is message, that it has a schema of type string, so it's a string, and it can be specified 0 or 1 times. So this is an optional input. Okay, so now let's look at how we can process in sync mode, which is, I would say, the default mode of operation. So the request looks like this. It's a post request to the execution endpoint, and we send it inputs. So in this case, we are sending a name equals Joe. And I'm going to ask for this to be run. Oh, sorry, I forgot to, what did I forget? I forgot, I didn't copy it correctly, sorry. Let's do this. Okay, so the execution was very fast. As you can see, here is our response. These are our request headers. No, sorry, this is the request call still, sorry. And the response is simply a JSON document saying hello, in this case, with the name that we sent it. This is a very simple process just to test the support of pygeoapi. And in this case, the sync execution is very fast, so we practically did not have to wait any time. If we meant to call it in async mode, the difference is that we need to send in this request header that says prefer a response of async type. And as the execution is a bit different, because we get back, instead of the results, we simply get back an acknowledgement from the server, this created message. And in the headers, there is a location header that tells us where we can go if we want to know more details about the execution. So in this case, let's just see what is in this URL. It's simply
sorry to interrupt. We have about 5 minutes. Okay, so
okay. So let's be a bit faster. Okay, so with this, I only meant to show you how the default pygeoapi processes support works. And now moving on to the Prefect stuff, we need to do some more setup. The first thing is to start the Prefect server locally. So I'm going to start it. I just need to activate the virtual env, and then I can run this to start the Prefect server locally. And this already gives us the Prefect UI that we can check out here. And for now, there isn't really anything there because we didn't do anything, but I'm going to show you very briefly how we can get it working. We need to swap out the manager from TinyDB to our Prefect manager in the configuration. So this is what I'm going to be doing also very fast. So I'm going to stop the pygeoapi server and sorry. Let's do this. And let's do what? Sorry guys, I'm trying to do everything very fast. You kind of not being able to. Okay. So let's just put in the other configuration. Oh. Here we go. So this, as I was mentioning, is the modification just to enabling the Prefect manager and the sync execution of jobs. And now let's put pygeoapi up again. And now, oh, sorry. I'm trying to rush everything, so it's not this command because this one was using the default configuration. We need to use this one, which is the one that has, oh no, I'm kind of falling apart, sorry. Here. Okay, so now we have a couple of messages when we start pygeoapi which are related to the validation of our parameters, because pygeoapi Prefect by default does a validation to see if everything is set up correctly. And now let's try to use it. So if we do an execution request now in sync mode, it will be using our different Prefect manager. As you can see, it takes a bit longer to come up with the result, but it's the same. And if we come back to the Prefect UI, we can see that now we have a registered flow here, which is just the way that Prefect names processes. And we have already a flow run here. So we have just a single one, but if I try to do a couple more, they will be showing up here in the UI as they are executed. Which gives us a way to monitor the let's say the execution of stuff, and when we do execution in async mode, which this would be an example. Oh, sorry, what did I do wrong? Let me try this. Oh, something is not going. Okay, guys, maybe we are out of time. I'm sorry, I'm not. I seem to have some problem here. I apologize that I guess I took too long to go through the introductory part. But the point I was going to make now was that if we were to make this, let's say, for example, 50 requests, we would see them on the Prefect UI just lining up here. First, they would be orange, and then they would slowly all become green as the execution would flow in an orderly fashion. If you are interested, please try to follow along at home. And thank you very much. I'm sorry for this delay. I don't want to keep you too long after time because you have other stuff to attend to. So this is it. I'm not sure. I don't know if anyone wants to make. Sorry.
No, thank you, Ricard. I appreciate it's hard to do like a demo like this in half an hour and to explain everything and then do the demo. Maybe next time we schedule more time for this. Just a quick question. Do you have like a Docker Compose file or something like that, or a Docker file to run this?
No, not really. Maybe I can prepare something, but it's not really necessary. I don't think. Unfortunately, this demo I kind of botched it. But if it were to have been, my point was also to show you how it was easy to install everything and run everything locally. But I guess I can prepare also some Dockerized examples, something like that, as I put in the slides. One of the things we are going to do soon is to improve the documentation with more examples and more ways how to use it. So definitely, I guess I can prepare something like that.
That sounds great. Did you leave the URL of the repository for this? Or maybe you can. Or even
I think it's in the GitHub Code Spring page, but I can put it in Discord as well.
Excellent. Thank you so much. So please stay
Thank you,
online,
guys.
and everyone stay online. I'm just going to move to the other room, but people online, you can all stay here, and we'll see you in a couple of minutes. Thanks.